Hi guys, my name is Dmitry and I'm going to talk about fractions in this video. I think a lot of people have some trouble understanding fractions, what they are and what we need them for, and how to manipulate them. So I'll try to clarify some of these concepts for you. And I have a slightly bigger goal for this video. I want to try to illustrate to you that math is not necessarily about memorizing a lot of complicated rules and just kind of blindly following them. Actually, most of math, it's possible to just understand it so well that you don't really have to memorize most of these rules. They'll just make sense to you and you'll be able to figure them out whenever you want to. So let's try to do this with fractions and see how it goes. So the first question that we should ask, of course, is what is a fraction and what do we need them for? And basically a fraction is a way to represent numbers that are not whole numbers. In other words, not numbers like 0, 1, 2, 3, 4, and so on. So you might ask, what other kinds of numbers can there be? And let me give you a simple example. Let's say we're counting cakes. So we have 1, 2, 3, 4, 5, and so on possible cakes. But we can also have fractional numbers of cakes. Let's say you have one cake and you have 3 people and you want to divide the cake into fairly for these 3 people so that each person gets the same amount. Well, what are you going to do? You're going to obviously cut the cake into 3 equal parts, and I have a picture for that. So in this case, we've divided the cake into 3 equal parts, and we call each of those parts 1/3. So in this case, the green piece is called 1/3, and of course each of those red pieces is also 1/3. But if I, for instance, take 2 of those pieces, then it's going to be called 2/3. So you can see the one green piece is called 1/3, and the 2 red pieces together are called 2/3. So these are just 2 simple examples of fractions. And you see, of course, how it's written. There's one number at the top, it's called the numerator, and one number at the bottom is called the denominator. And let me show you this just in case. So once again, the number at the top is the numerator and at the bottom is the denominator, and the meaning is pretty clear. Just with this one example, I think the number at the top would be the number of pieces that we select for whatever purpose we need, and the number at the bottom is the number of total pieces that we've cut the cake into. Well, we can cut the cake or anything else. In fact, let me give you a different example here. So here I tried to draw a piece of chocolate, so a square piece of chocolate, and I have cut it into 4 equal parts here, and I want to eat 2 of those parts. So the pieces that I want to eat, I've shaded green. So the question is, what fraction does this represent? And of course the answer is going to be 2/4, right? Because I've selected 2 pieces that I want to eat or whatever, give to a friend, but the total number of pieces is going to be 4, right? So this is the fraction 2/4. Now, why did I, instead of drawing a regular line between the numerator and the denominator, why did I put this thing parts out of? The reason I did that is because I think that's a good way of thinking about fractions in general. In this case, we've selected 2 pieces or 2 parts out of total 4. So you can sort of think of this line that separates the numerator and the denominator as representing the words parts out of. So whenever you see a fraction, something like 2/4 or, I don't know, 3/100, just think of it 3 parts out of a total of 100. Okay? And now I'll give you a few more examples of fractions just to make sure that you've understood the idea. Now all of these fractions represent something from the real life, and I want you to think about what could they possibly represent. So you can pause the video if you want to and just think about this, and then I'll assume that you've paused it, and I'll tell you what I think all of those fractions might represent. So let's start with 3/7. So just think about something that is naturally divided into 7 equal parts. And a good example would be a week, right? Because a week is naturally divided into 7 days, right? So 3/7, that could be 3 days out of 7 total. So in other words, if I say have Monday, Tuesday, and Wednesday, those 3 days would represent 3/7 of a week. Now let's do another fraction. Let's say 5/60. So again, think about something that is naturally divided into 60 equal parts. And a good example would be a minute. A minute is naturally divided into 60 seconds. So 5/60 could be 5 seconds out of a total of 60 seconds. So 5 seconds is 5/60 of a minute. The next example we can do is 1/12. So what is naturally divided into 12 equal parts? Well, a good example would be a year, right? So a year is divided into 12 months, and 1/12 would therefore be 1 month out of a year. We have 2 more examples. I think you can probably do the next one, 7/365. That could be 7 days out of a total of 365 days per year. So 7 days would represent 365th of a year. And the final fraction here would be 20/100. Now, what is naturally divided into 100 equal parts? Well, one example would be $1 is equal to 100 cents. So therefore, if we select 20 of those cents, that would be 20/100th of a dollar. So 20 cents is 20/100th of a dollar. Now, take a look at these fractions again. I've actually kind of lied to you a little bit about one of these fractions. And it's a bit of a tricky question, but you might want to think about it. Which of these examples that I've given you that represent those fractions is not completely correct? And I'll probably tell you the answer not in this video but in the next one, but just think about it if you want to. Now I'm gonna give you 3 more questions to make sure that you've understood what fractions are. So take a look at these questions. The first one is, what is greater, 1/10 or 1/100th? So again, you can pause the video and then try to answer it on your own. I'm going to assume that you've done that, or you just want to hear the answer. So the answer is this. I'll just explain to you my reasoning. So let's say we have a cake and we've divided into 100 equal parts, right? So the parts will be pretty small, obviously, right? Now, if I have the same cake and I've divided it into 10 parts, the parts might be pretty small, but not as small as if I divided it into 100 parts, clearly. So the answer is 1/100th is going to be much smaller than 1/10, even though the denominator 100th here is actually bigger than 10. Now, the next question here is, what kind of a number is 4/4? Now, it's kind of a weird fraction, right? The numerator is the same as the denominator. So think about this. Let's say I have, again, a cake, and I've divided it into 4 equal parts. And I've selected not 1, 2, or 3 of those parts, but I've selected all 4 of them, right? So that would represent the fraction 4/4. But of course, if I select 4 out of total 4 parts, that means I've selected the whole cake. And since a cake represents number 1, so 2 cakes would be 2, and so on, 4/4 is just equal to 1. Okay, now the final question I want to ask you is, what kind of a number is 0/7? You can think about it in the same way. Again, you have, let's say, a piece of cake, or a piece of, not a piece of cake, you have a whole cake or a whole bar of chocolate, and you've divided it into 7 equal parts. But now again, instead of selecting 1, 2, or 3 of those parts, you actually select 0 of them. So you take nothing for yourself. And of course, nothing in math is called 0. So 0/7 is equal to 0. And I've put all of those answers for you in this one picture so that you can review them again and make sure you understand them. And now we'll move on to a slightly different topic, adding fractions. So here, take a look at this example. Here I drew a fraction 3/8 for you. So I have a cake that's divided into 8 equal parts, and I've selected 3 of them to represent the fraction 3/8. Now, what if I want to add, let's say somebody wants me to tell them what is 3/8 plus 1/8. How would I do that? Well, instead of just trying to remember a particular rule or something like that, let's just think about it just from our understanding of fractions. So here we have 3/8, that's represented with green, and now 1/8 would be some other piece. So let's say these three pieces are 3/8, and this piece is 1/8. If we add them together, that means how many pieces in total do we have? And of course, in total, we're going to have 4 pieces. 1, 2, 3, 4. So the answer, since each piece is 1/8, the answer would be 4/8. Right? So 3/8 plus 1/8 is 4/8. So I hope that makes sense. And just to give you a slightly different example, let's say we want to add 3/8 plus 2/8. I think you can understand what that should be. 3/8 are those 3 pieces. 2/8 are, for example, this and this pieces, or any other 2 of them. But in any case, in total, we have 5 pieces if we want to add them together. So the bottom line is that 3/8 plus 2/8 is going to be equal to 5/8. And I hope that makes sense, but just in case, here's the review. So 3/8 plus 1/8, we just add the pieces together. It's going to be 3 plus 1, so in total we have 4/8. And the same with adding 3/8 and 2/8. Okay, I hope that makes sense. Now let's do a slightly different example. We're not actually going to finish it today, but just to set it up, let's say we have this problem. We want to add 3/8 plus 1/4. Now here it's more difficult because we can't just do the same trick as before. So I drew 3/8 for you here, represented in green. So we have 3 pieces out of total 8. And on a different cake, I drew 1/4. By the way, 1/4 is also called 1/4. So it's shaded red here. Now before, I just added pieces together, right? Because they were the same size. But here I can't really do that. I can't say, well, I have 3 pieces here and 1 piece here, so I'm just going to have 4 pieces in total. I will have 4 pieces in total, but they're different size, so I can't say it's 4/8 or 4/4 or anything like that. So it's not as simple, and we're going to tackle this question in the next video. And until then, you can just do more examples. Just think of possible examples of adding fractions, comparing fractions, and also think about this tricky question that I gave you, which of the examples of the fractions that I gave you is not quite correct. So hope to see you in the next video.